the help of the decoder. So address bits consisting of the only 8 lines that may be coming from the either lower order address line A0 to A7 or the higher order address line A8 to A15, because the content of this lower order and the higher order address bytes are the same. So it is an example of all the address lines over the lower order address bus has been utilized to form the absolute decoding. But if we do not connect any one of the address line, then definitely the duplicate addresses will be formed for IO access out of 256 unique address space. So this is an input device also. How an input. This is also an example of the interface and input port. This is the external line, that means from where the digital signals will be coming out, and this is the actual tri-state buffer, octal tri-state buffer. The output of the buffer is connected to the data bus. So this is a typical circuit diagram how the input device can be interfaced following the absolute decoding method. Output device, in case of output device, the same things will happen. These are typical examples. In case of a memory mapped IO, the circuit will be different. But in case of a memory mapped IO, so definitely the latch will be required, because the whole 16 bits, 16 address lines will be utilized. And these are the comparison between the IO, memory mapped IO, and the address IO mapped IO. So keeping in view with this concept, now we are moving to that important input-output device called the Programmable Peripheral Interface Device, PPI. The chip name is 8255. Because the PPI device, according to the internal block diagram, these are the pinout description. 8255 has 40 pins. So it has 3 IOs. 3 IOs in a single chip. All types of the IO have an individual 8 number of lines, as indicated PA0 to P7 for A port. This can be utilized as an program for an input and the output also. There is a PV port having 8 lines, PV0 to PV7, and there is a PC port which is divided into 2 parts as PC0 to PC3, that is the lower order C port, and another part is PC4 to PC7 as upper order C port. So counting all the line, we have 3 into 8, 24 number of the IO lines in a single package called 8255. And these sites indicate how the lines will be connected, address data to the 8085. So the chip select signal will be coming from the IO decoder circuit. A0, A1 are connected to the, which is called the 2-bit address lines, which will be connected to the address lines. Read bar, write bars are the timing and the control signal basic, which are connected to the 8085 read bar, write bar line. And the reset line is connected to the reset out of the 8085. So these are the block diagram of the Programmable Peripheral Interface, PPI. Now, which is very important to learn how to program, what will be the mode of actions with the help of the instruction, the command, which will be put in the read-write control logic. So according to that means it is required essentially to configure the mode of operations for the 8255. What are the mode of operation? So that is given. what are that is called the operating modes. So there are three basic modes of operation that can be selected by the command word or instruction during programming. First one is called the mode 0, which is the basic input-output mode of operation. Second mode is called the mode 1. The Strobe input-output mode is a special type of mode of operation. And the last mode is mode 2, called mode 2 is called bidirectional bus. So that means what is the difference between the first and the third mode? That means in the first mode, only at a time, any one of the port lines can be used as an input mode, basic input or output, not mixture. But in the mode 2, it is bidirectional at a time. So that is the difference. So how the program, it is the logic circuit for mode 0. So this part is the bus line connected to the microprocessor. This is the IO decoder. This for mode 1. In mode 1, what is the difference between the mode 1 and the mode 0? In case of a mode 0, all the 8 lines associated with the individual port A, port B, port C can be programmed as a basic input mode, a basic output mode, or mixture of them, combination of them. So that is why it is called the mode 0 operations. Basic, simple, but in case of a that is a second mode, it is called the Strobe input-output mode. What is the meaning of strobing the signal? This mode of operation is like that. So the port B has an 8 lines marked as PB0 to PB7. But the C port, the lower order C port, consisting of these 4 lines, PC0 to PC3, 4 lines, PC0, PC1, PC2, PC3. So that means during reading and writing, port C0 lines can send the interrupt request signal to the other microprocessor. PC1 is what? It indicates the output buffer of the port B. What is the meaning of the output buffer? That means according to the block diagram of 8255 PPI, so the data during writing, the microprocessor puts into a latch. There are 3 latch associated with the 3 ports A, B, and C. Similarly, during reading operation, the external signals will come to the latch. So it is basically an octal registers. And the microprocessor will read from the latch during read operation, and during write operation, it will put the 8-bit digital value to the latch. So that it will be latched, the logical levels of the 8-bit data will be passed or transferred to the physical port lines. So what will happen? In the strobe mode, it indicates that is the latch is full, a latch is full, output buffer full, OBF, which indicates the output buffer full. So that the other microprocessors, that means there may be other 8255. So it gives an acknowledgement signal, that means yes, do not send the data until and unless the microprocessor reads the stored data. It will not become empty. And once during interrupt operation for data transfer parallelly, the interrupt INT or B signal will act. It will pulse to the high logic. Now there is another signal which is called the strobe acknowledge signal, which is associated with the PC3, PC2. That means the other PPI device that will give the acknowledgement signals from this IBF. That means once the IBF will be accepted by the other PPI device, it will generate the strobe acknowledge signal. So that upon it is an active low bar. So upon receiving the Strobe acknowledgement, that means yes, the other PPI device has acknowledged this signal. That is, so accordingly, it will put the data again over the port B. And this part is the same function over the port A, that is 4 lines. So this is the meaning of the functions of the Strobe input-output mode, which is very fast for data transfers between the two PPI, 8255 based PPI. And in case of a mode 2, it is a bidirectional. That means at a time, the port B can be used as an input-output. Port A can be used for the bidirectional input-output. And PC0, PC1, PC2 are used as an 3 input output lines in combination. And these lines will act as an Strobe mode for bidirectional. So it is the fastest operation under mode 2. Now, what will be the mode definition which will be required so that during programming, the 8255 internal ports A, B, C will be configured accordingly. We can see D0 in the relative order D0 to D7, which has its own significance. The combination is so. That means the group A mode. Group A mode means A port can be used for mode. Sorry, it is a group A mode. That means 3 modes can be put when the bit content will be according to this description 000110. D4 bit signifies which port is to be configured according to this mode of operation, whether it is port A or port B. So this is for port B, D1. And this is for mode of operation associated with the port B, D2 bit. D0 and the D3 are associated with the upper port C and the lower port C. So this will form the command word or the command byte. And this byte should be sent to its control registers inside the block diagram, read-write control logic. So during programming, there is a sequence. That means, first of all, the control mode should be sent by the microprocessor so that the respective ports should be configured. Then the read-write operation will follow or proceed. And there is another operation, single bit set reset. So that will explain what is that. So according to the examples of the interfacing of the PPI device, what are the states for basic operating mode? Mode 0, that is basic input-output mode, which states this mode provides simple input-output operation for 3 ports. After the mode is set, that means when the control word or the command word will be sent by the microprocessor to the 8255, the data is simply read from the or written to the ports. The mode 0 functional definition are like this. If both the groups are programmed in mode 0, it consists of 2 8-bit ports and 2 4-bit ports. Why 4 bits? Because that means in mode 0, A, B port can be programmed as an input-output mode. So that's why it is the 2 8-bit ports, and the port C, which is configured as a 2 independent individually 4 bits, which will form the 8-bits line. Second step is any port can be programmed either as an input and or output at a time, but not that means at different time. It is not at a time, like bidirectional IO mode of operation. So 16 different combinations of the input-output configuration are possible. All ports may be input or all ports may be output, or few inputs and the few output. That means there are port C, that there are 2 different 4-bit ports. The data written to the output ports are latched, which I have just explained, to the output latch. Inputs are not latched, but only buffer are provided. writing to the mode registers, that is mode control register, resets any bits that are output. The default output of the ports bits programmed is output mode. That means even though the microprocessor even though the microprocessor do not send the command word or the control word to the 8255 control register, all the ports will be set to the output port by default. That is, upon power on reset, all the port lines will be configured as an output port. This is an example. Configure 8255A in mode 0 with different ports in input mode as below. Port A input, port B output. And PC output, PCL, the upper byte, upper port, PC, upper C port and the lower C port, PCL. The control word to program the 8255A as above will be like that. 9 word. The control word will be computed to control word registers having add 03. The relevant instruction will be like that. First of all, the control word which has been determined according to this bit definition 9-1, that will be loaded immediately to the accumulator and sent to the respective control port, the address of which is 03 for a specific example. So how many address will be there? First, one address is for control register address, and the rest 3 addresses, separate addresses, will be for A, B, C port. So there will be 4 IO addresses. That's because 8255 PPI has 4 IO devices in a single chip. That's why there will be 4 addresses. So this is an example. In example 2, you can go through in a similar life. In example 3, this is a separate example for interfacing the A to D conversion, which will be read afterward. Only you can follow the example 1 for a basic input-output port. Now, the same things have been explained here with the example, programming example. The example shows that means interface 8255 with 8085 microprocessor and write an assembly language that determine the addition of the contents of the port A, port B, and store the result in port C. That means it will read the 8-bit content from port A and port B, it will sum, add, and it will store to the port C register. So this problem includes the reading of the 2 ports A and B and writing to a C port. So these are mode control word which will be set to the control registers. And these are operations. So what is the algorithm and what is the program counter? Algorithm is very simple. Construct the control word registers first. This is the control word registers or byte control word for the control word register. Input the data from port A and port B. Add the contents of the port A and the port B. Display the result in port C. Display means send the addition, result of the addition to the port C. And this is a typical assembly language program. Here, in example, the 90 is the control word port address. There is control register port address. This should be moved to the, 90 is the control word according to this bit definition, which will be sent to the control registers. The port address is 83. Then read the port from the A port. Here, A port means the address is 80. And it will store to the B port. Again, because Upon reading, the content will go to the accumulator. So by the instruction in 80, and temporarily it is stored to the B register. These are the comments. Read the content of the port B by this instruction. The address of the port B is 81. That means port B data registers. So already the one that is the content of the port A has been stored to the B. Now the content of the port B is moved to the accumulator of the A registers. So now we can use this command addb. That means it will perform the addition, and ultimately after the result of addition, it will be in the A registers, which will be written or sent to the port C register, the address of which is 82. And these are last instruction return, because if we consider these a subroutine, otherwise there will be a halt. And these are the explanations which I right now I have explained to you. So this is a typical example. You can go through the more and more details from this write-up. These are already elaborated in the previous slides. Example 1, find the control word of this 8255 following the configuration. All the ports A, B, C are the output modes, mode 0. And the command word will be 90. So you do not consider this one because it is a separate things. Microcontroller. It is separate things. Microcontroller. This is not applicable for you. This is not applicable for you. This is for interfacing 8255 PPI with a microcontroller, not microprocessor. Same for this. This is not applicable. All these things are for microcontroller. These are microcontroller. So this is a in-depth explanation of how the 8255 can be interfaced to the 8085 with the respective pins, and functional diagram looks like the same things. This is applicable for your notes. This is a better demonstration how the operating mode, that is a tree of operating mode, and the respective explanation. So strobe mode sometimes is called the data transfer with the under handshake. So that's why handshake signals, these are called the handshake signals. The handshake signals will be generated, associated with the port C, lower order port C and the upper order port C, for the two ports, A and the B. Now, this is also same things, same note. Now, what is the application of the port? Because IO ports IO ports can be used for interfacing the different types of the application circuit. For example, interfacing the 7-segment LED display. We know the 7-segment LED display is available in the form of the chip. So it is either common anode type or common cathode type. So this is a typical common cathode type display. That means all the segment lines are available and they are marked as A, B, C, D, E, F, G with a decimal point. So the 8 segments, pin lines of the 8 segments are drawn out, and this is a common segment. In fact, in between them, 8 number of the LEDs are available inside the chip. So that means if we apply a high logic, this LED will glow, this segment LED will glow. So all the segment LED will glow to form a particular characters, display characters. So these display characters consist of all the 9 decimal symbols 0 to 9, including the decimal point. So this is the common anode type, where the common terminals are called the anode, which should be connected to the 5-volt power supply, and all the segment lines should be at a low logic, so that the respective LED segment LED will glow on. Otherwise, they will glow off. So that is the operating principle of the segment LED, and these are the segment display, that is which display the 10 number of the decimal symbols. So this is an example. That means how this is a truth table for displaying the character. The truth table is called a decoder circuit, display decoder circuit, that is eight number of the input segment. So these are the don't care, either maybe low or high. So then the character 0 will glow. Similarly, to display the character 4, this will be don't care, and this will be either high or low, like that. So anyway, so this is the truth table. Now, a driver circuit driving a LED 7-segment display, we can test using a current limiting resistors of 220 ohm value for a common anode type 7-segment LED. But if we use a 7-segment decoder, and what will happen? According to the input logic having 4-bit BCD, what will be the value of the segment by the BCD to 7-segment decoder circuit? In the digital electronics, you can go through this type of decoder, that is BCD to 7-segment decoder. That means input is a 4-bit, output will be a connected by the current limiting to the is for common cathode type. Now this display to be connected with the interfacing PPI, interfacing circuit logic PPI. So this is the interfacing circuit for display. But in respect of single digit, 8 digits have been interfaced to form 7-segment multiplex display. Otherwise, you can connect the single display to the port line. What is that? That means one single 7-segment display to be interfaced with a 7-segment decoder. So the input of the decoder will be directly connected to the 4 port lines, either A, B, C. So that is the simple logic. But generally, the 7-segment display having multiple digits must be interfaced with the help of a single API according to this circuit diagram. Here we see the 4 digit, each digit is a 7-segment display, and there is a digit drive signal which is connected to the 4 driver transistors. So what type of the 7-segment display to be used, we can see from the logic diagram. That means when this is high, when the digit signal will be high logic, when this transistor will get the base bias signal from the output port, that means when this port line become low, the transistor will conduct, and the common line must be anode. So each 7-segment digit follows the common anode type logic. And simultaneously, according to the truth table, the output lines, that means the number should be low. So according to the truth table. So this is the truth table. Already the truth table can be calculated from this diagram. What literal of the character to be displayed with the 4-bit numbers, BCD number. So this is called the multiplex type 7-segment display. That means we can use a particular algorithm or the logic so that first the digit drive signal should be enabled by the separate port, maybe output port B from the 8255. At the same time, the BCD number should be passed to the output port A, and it will be decoded by the 7447. The 7447 is what? It is a common anode 7-segment decoder. Common anode, because it is connected to the common anode type 7-segment display. Otherwise, there is another type of display decoder called common cathode type. The number is 7446. So this is a typical diagram how the multiplex. Why multiplex? That means at a time to display a particular number having 4 digits, either from the most significant digit or from the least significant digit, the character to be displayed for the small duration. How much? That will depend on the persistence of the vision. That means at a time, this signal should be made low, so the transistor will conduct. At the same time, the number corresponding to this digit position should be sent to the another port A. So this will display, and this system is repeated until the most significant digit character will be displayed in a very fast manner. How? The interval will be according to the theory of the persistence of the vision, it will be within a particular millisecond duration. Otherwise, what will happen? It appears that means this digit will glow on, then following a time delay, this will glow off, then the second display will glow on, and this will be repeated. But the time duration for successive display will be like that, interval will be very, very small. So that when the duration is small, all the significant digit will glow on simultaneously. It will appear. So that is the theory of interfacing a 7-segment display, multi-digit 7-segment display, following the multiplex display method. So these are the example by which we can utilize the 8255 port for displaying a decimal digit having multiple digits. So did you follow the logic? That means how the 7-segment display can be interfaced with the help of the 8255 port via the display decoder. One of the basic advantage of using the port is what? That means if we connect the 4 digits, 4 7-segment display digits, how many port lines would be required? Here it is 8, here it is 8 separately. So 8 into 4, 32 port lines. As well as plus digit select line 4. So 32 plus 4, 36 port lines separately would be required. But following this multiplex display technique, we require only 8 plus 4, that is only 2 lines. Again, we have used the display decoder. So in effect, we require only the 4 plus 4. So only 8 port lines are sufficient to drive the 7-segment multiplex digit. If we add another display, this will not increase, but 1 digit drive signal has to be added. So the 5 lines over the port B will be connected. In 8255, each port has an 8 line. So in an effect, we can interface 8 number of the 7-segment significant digits by this technique. So data line, because we are using the display decoder. Otherwise, it would be 8. So if we omit this thing, the 8 lines will be connected to the port A. And port A has only maximum 8 lines. But including the display decoder, we have only 4 lines because we are using the BCD to 7-segment decoder logic circuit according to the truth table. So that is the advantage. Now, did you understand how the multiplex display, 7-segment multiplex display can be interfaced with the help of 8255 PPI to the, that means a microprocessor based display technique. So this is one important example. Then the another example is interfacing the push button of the keyboard to the via the 8255 port. What is that? So this is a simple single push button circuit. When the switch is pressed, this will be grounded, so the PA0 lines of the 8255 will read the low. Otherwise, when the switch is open, this point will be at a high logic, so the PA0 will read high. So extending this idea, a matrix keypad or matrix keypad can be interfaced according to this logic diagram. According to the logic diagram, this will be described in detail. That means interfacing the matrix keypad. Interfacing a matrix keypad. What is the matrix keypad? That means matrix keypad is distributed in configured as a number of row and the column line. So we can see the 4 row lines and the 4 column lines are available to form a matrix keypad. The total number of the push button is 16. So these are called the column lines and these are called the row lines. The 4 row lines are connected to the 8255 PPI and the 4 column lines are interfaced to the 8255 PPI, another port B. Now to sense the one key press, because when the key is pressed, what will happen? First of all, when the key is unpressed, all these port lines will be at a floating logic or will be at a high logic, because via these lines, all the potential will be at high logic. As well as all these column lines will be at a high logic because they are connected via these 4.7K lines. So when the keys are not pressed, so this port will read all 1 and this port will read all 1 in general. But the technique is like that. This port will be configured as an output port. So at a time, 1 row lines will be put a 0 logic, keeping the other rest of the lines will be at high logic. So what will happen? When this will be done, and when any one of these row lines, the key switch will be pressed. So what will happen? So this line is at low logic. So when the key is pressed, then the current or this line will go to the low logic and this will be read by the another port line, respective line. So sending 0 to 1 row lines, and when any one of these lines will be pressed, key switches, so the bit pattern will be 4-bit lines. Bit pattern will be what? All 1, that means 1 1 1 0, and to detect the key switches which are falling over the row line, it will be maybe either it will be 0 or it will be 0 or it will be 0 or it will be 0. So this will form 4 combinations. This sequence will be repeated by pulling these D1 lines to 0 and keeping all the lines to high. So that what will happen? For the upper 4-bit, it will be 1 0 1 1. So for this selection row, any bit pattern can be formed if any push button falling on the row 2 will be pressed. So by this way, it is possible to generate the 16 number of the 8-bit code. So each 16 number of the 8-bit code corresponds to the one single key press. But if more than one key is pressed, that may happen. So the logic, there will be logic to reject the key sense. So I will discuss what is the algorithm for the key sensing logic. So that is an untypical example how the matrix keypad can be interfaced via 8255 port to the microprocessor 8085. Only thing you have to understand the logic behind this, how to read the code from the pressed key, and for that purpose 8255 PPI is required. So the PPI is required in general for displaying the 7-segment display as well as the interfacing the matrix keypad, which is a combination of the m into n number of the push button in a row column distributed fashion. So did you understand this logic for interfacing the LED, a 7-segment LED display and the matrix keypad via the PPI 8255? So there are so many other examples, that means how the 8255 PPI can be interfaced. Another example is ADC and DAC operation, analog to digital conversion, digital to analog conversion. I think you are not fully conversant or familiar about the ADC and the DAC operations in analog electronics. That means when the digital data has to be converted to the analog signal, as well as the reverse operation when the analog signals, electrical signals will be converted or to the digital format. So that is called the ADC and the DAC operation. And microprocessor can do this operation without any integrated circuit. That is the DAC and the ADC integrated circuit. By using the logical operation, easily the ADC and the DAC operation tasks could be done. So this is an example of the PPI. We will discuss more detail in the next class. So interfacing ADC and interfacing DAC. So the ADC chips are available. Chips is nothing but a peripheral device which can be connected to the 8255 PPI. And what are the sequence diagram? That means what are the programming steps? These are given. And this is for ADC operation or for DAC operation. What are the different types of the ADC? You can go through the counter type ADC, successive approximation type ADC, so many things. So we will discuss in detail for ADC DAC operation. Then there is also DAC interfacing. We see concept of interfacing the D to A converter, how the digital lines will be converted to the analog lines with the microprocessor. So these are examples which are available in the ground curve book. The circuit diagram is like that. And these are the typical software code which uses the delay routine, timing delay using subroutine delay to generate the binary code so that the analog value will be produced by the DAC chip 1408. So these are interfacing circuit for DAC. So there are so many applications of the peripheral device, programmable peripheral interface, PPI 8255 is one. There is another important programmable peripheral interface 8155, which includes the multiple ports as well as a timer. So timer as well as the RAM, 256 bytes RAM. So 8155. So 8155 is another important peripheral programmable peripheral interface, which includes the ports as well as the memory chips, external memory chips, 2 kilobytes, and a timer, 14-bit timer or counter, timer counter block. So I will discuss about them because these are included in the syllabus, but sometimes the questions are not set on programmable interfacing the timer, the 8255. But 8255 is an important operating description, and the functional description of the 8255 is very, very important. So if you have any questions about the interfacing of PPI, then you can ask. Did you got the point or logic? 7-segment display logic and the matrix keypad logic. Hello. Do you have any questions in your mind? Then please ask. Do you have any questions?
No, sir.
I think if you have, did you receive the last class keynotes? Interrupt. Process of interrupt, interfacing, how the interrupt can be initiated, vector interrupt like that. Did you receive the note? I think you have received. Anyway, it will be again checked whether that has been sent or not. So only I think fewer classes are left for ending the course. 1 or 2 classes sufficient. In Wednesday is a suitable day according to the routine, but are you engaged in Wednesday around 12 noon? Then I can take the class in the coming Wednesday.
No, sir, we have class.
You have class, okay. And in the evening on the same day, Wednesday, do you have class on the same day in the evening? Other than Friday, like that, like on today. If you are free to attend the class on Wednesday in the evening, then please inform me so that I can attend the class. Okay, I'm leaving today. Okay.